Hello, my name is Swapnil Pranto Mistry, student ID 200204, and my teammates are Sakib Mahmud Sovon, student ID 200203, and Zahid Hasan Rabbi, student ID 200205. Today, we are excited to share with you our project on New Sweep and obstacle avoidance car using Arduino Uno. The sections we are going to present to you about this project are the introduction, the objectives of this project, what is the uniqueness of this project, the working principle of the bot, the results got from the project, and the future steps could be done in this project. So let's dive into it. In this busy world, it is such a painful work to clean our room time to time. As a result, our room get dirty. For the solution of this problem, we present you the cheapest and effective solution, NeoSweep, the automated floor cleaning bot. The main theme to do this project is to develop a cheap autonomous cleaning system that is efficient and effective. We use ultrasonic sensors to detect obstacles and avoid collisions. We created this project to demonstrate the potential of combining ultrasonic sensors and motor drivers to create an obstacle avoidance system for a two-wheel car. With NeoSweep, we can explore the use of components to build more advanced robotic systems that can interact safely with their environment. So we also attempt to design a system with a sufficient battery life to clean a room. So you can ask, what are the uniqueness while there are many obstacle avoidance systems out there? We can say that NewSweep stands out because of its simplicity and cost effectiveness. By using affordable components and Arduino Uno microcontroller, we are able to build a functioning obstacle avoidance system that can detect obstacles in front of and on the sides of the car and adjust its movement accordingly. So what are the materials and methodologies? The materials we used to run this project are Arduino Uno R3 microcontroller, L298N motor driver, ACSR04 ultrasonic sensor, caster wheel, battery, DC motors, and DC to DC buck converter. These are the main components we used. So here are the pictures of the components we used mainly. You can see the Arduino Uno here, the motor driver for two-wheel car, and we used three ultrasonic sensors for our project, and we used a DC to DC buck converter to convert the 12 volt into 5 volt output. So this is the schematic diagram of wiring. We connected the motor driver to our Arduino Uno, and the pins of the motor driver in on, in 2, in 3 and in 4 are connected to control the rotation of these motors clockwise or anti-clockwise, and the ENA and ENB pins are connected to control the speed of these motors, and the three ultrasonic sensors are used to detect obstacle front side, left side and right side of the car. So this is the flowchart of how our project or the car is going to operate. Firstly, the car start and it initializes the motor control pins and ultrasonic sensor pins as input and outputs. The default speed for the DC motors have been set in this stage, and first of all the Arduino Uno checks that if there is any obstacle found in front of it. If it found an obstacle less than 20 centimeter, then it's send the signal and then it checks for the left sensor. If there is any obstacle, then it checks for the right sensor, and if there is also obstacle, then it moves backward. Otherwise, if there is obstacle in front and the left, then it moves to the right, and if there is obstacle in the front but not in the left, then it moves to left. Otherwise it always move forward and resume moving forward and continue cleaning. and after some time it stops when the battery is dead, and it stops the motors and turn off the bot. So we would like to show you the coding section for this project. So in this Arduino Uno IDE, I've selected the A0 to A pins for the ultrasonic sensors. Trick pin on and trick pin echo pin on is for the sensor, and pin 2 echo pin 2 is for the left, and trick pin 3 echo pin 3 is for the right sensors. The ENA and ENB is connected to pin number 10 and 5 in the Arduino for controlling the speed and for controlling the rotation of the motors. Pin number 9 to 6 are selected for on to in4 of the motor driver. The obstacle threshold is initializes for 20 centimeter. Loop function here, you can see that logic is implemented. The distance from each sensor is calculated first here, then they are checked the if else statement. So when there is no obstacle in front of the car, that means distance is greater than 20 centimeter, the car move forward. Otherwise, if the distance get from the front sensor is less than 20 centimeter, then it checked whether there is obstacle in the left. If not, the car turns left. But if there is also obstacle in the left, then it is checked that there is obstacle in the right or not by this condition. If there is no obstacle in the right, the car turn to right. And finally, if there is obstacle in front, left and right, the car move backward, and the checking continues by this loop function. We have implemented the move forward, turn left, turn right, and move backward function here. In the move forward function, you can see that in on pin is low and into high. This implies that the left motor is rotating forward, and to 4 is high, that means the right motor also moves forward. The opposite is done in the move backward function. You can see this here. The in on pin is set to high and in 3 is set to high. To turn the car left, in on pin is set to high and into pin is set to low, and in 3 is low, in 4 is high. This implies that the left motor is turning backward and the right motor is turning forward. This happens, then the car turn left, and the turn right function, you can see that the opposite is done here. Okay, this is all in the code section. So let us go back to the slide. Okay, so experimental results sensors we have are shown here. Here that when the distance is greater than centimeter for the front sensor, that means there is no obstacle, the robot forward, and we have succeeded in this testing. There is any obstacle less than 20 centimeter, that means there is obstacle in front of the car, the cleaning bot stops, then turn left or right. So depending on the condition, there is any obstacle in the left and front, then the bot stops and turns right, and if there is obstacle in front and right, then the car moves to left. And if there is obstacle in front of the car and left and also in the right, then the car stops and turn backwards, and this continues. We have already seen in the previous coding section that this checking always goes on and on. So we have validated all these conditions and found that the sensors are working properly. So what is the next goal for our project? So new sweep is just the beginning. In future we have planned to explore the use of more advanced sensors such as infrared lidar sensors to improve the accuracy and range of obstacle detection system. We also plan to develop a more advanced control system that can handle more complex scenarios and avoid obstacle in real time. Overall, it demonstrates the power of combining simple components to create a functioning obstacle avoidance system. Thank you for listening to us, and we are now going to show a demo video of how our robot operates to clean the dirt and dust from room by avoiding the obstacle in front of it. Thank you.